Alright, WHS Juniors, welcome again to another scintillating math video. Today's particular topic is going to deal with exponential growth and decay, where we actually make something bigger or smaller via multiplication. Okay? So we're going to talk about how that occurs and how that can be modeled, and then how the graphs will look for that. Certainly something that's going to be on the MCA grad, or just the MCA part of that thing itself. Alright? Basically, there's an idea behind growth and decay, and it starts with this. I am Mr. Kohler. I'm 215 pounds. Say today I eat my normal intake of food, I don't hardly exercise, and like another normal day, and tomorrow I come back and I'm exactly the same weight. So if I said, what did I multiply myself by to come back exactly the same way as I was yesterday, what would you say? I hope you'd say, Mr. Kohler, you multiplied by 1. You brought back yourself. You multiplied by 1. Okay, now if I want to make myself bigger, and I go home tonight and eat some pizzas and have some buttered popcorn and some, some regular Mountain Dew for a change rather than this diet stuff, I could actually gain a % of weight. Okay, for me it would be gaining about 2.2 pounds. But if you gain a %, no longer would I be multiplying myself by 1. I'd actually have to add 0.01 onto that, and I'd be multiplying by 1.01, which makes me bigger. That's called exponential growth. Anytime you multiply by something bigger than 1 plus something, you're going to grow something up, and it grows pretty fast eventually. All right, now there's a flip-flop of that, and that'd be like if I was going to stay on this diet I'm on, and say I eat right today and I exercise, and I lose a % of myself overnight magically, and losing a % would be taking a % away from 1. 1 always brings you back when you multiply. If you multiply by bigger than 1, you're getting bigger. If you multiply by smaller than 1, you're actually reducing something. So if I reduced myself by a %, I'd be coming back tomorrow as 99% of who I am from a physical standpoint. I'd be 0.99 of what I was. Okay? People talk about investing dollars, and they want to gain, they want growth. Well, if you can get 5% growth on something, all right, it would be multiplying by 1 plus 0.05, 1.05, it'll grow that up. And if you keep doing that, it'll really grow and grow and grow. Likewise, if I lost 8% on an investment year after year after year, I'd have to subtract 8% from 1, and I'd be multiplying by 0.92. Now, people think when you multiply, you always get bigger. That's not true. If you multiply by 1, you stay the same. Bigger than 1, you get bigger. But smaller than 1, if you take away from 1, you're reducing. All right, so here are the models for this. You're always starting with who you are, and you're multiplying by 1. If you want it to grow, you have to add whatever the rate of growth is. I'm going to put R for rate. Okay? That's called the growth factor. And then you can have a power involved here, you guys. Usually it's going to be some time frame you're talking about. It continues to do this year after year after year or whatever. And then the idea is, if you want to make something smaller, you don't add the 1, you subtract away that rate. In this case, that rate decay, and for a period of time. So, this is the idea. And it looks like number 2, I've kind of got the same idea here again. Say I let C be the starting amount. If I want to grow it, it's 1 plus the rate. If I want to decay it, it's 1 minus the rate. Essentially, are you adding or subtracting from 1 to grow it up or to decay it down? Okay? So keep in mind, 1 is break even when you multiply. Growth has to be added on to 1, decay has to be reduced from 1, and you go from there.